Alright, we're going to be working on 10.1.3 GCF and factoring by grouping. So what we're going to be looking for at the beginning of all these problems, and then every problem kind of moving forward in this factoring section, is there something that we can take out? So I'm going to go ahead and look at question one. What am I actually on? Yeah, look at question one, and I'm going to break this down differently. This is 3 times x times x plus 6 times x. Alright, so I just expanded it out. Now, one thing so we're going to be looking at the first part, which is the 3x squared, and then the second part, which is the 6 times x. We're going to look at what they have in common. Well, the first thing I see that they have in common is they both have an x. Alright, so they both have an x. What else do they have in common? Well, they have no other, they just have a singular x, and then they have the numbers 3 and 6. Well, what we'll need to know is like, hey, 6 is technically 3 times 2. So I can just break 6 down that way. And what that will tell us is that we also have a 3 in common. This is kind of like an elongated way to do this. I'm just trying to show and prove the point. So I've seen now what the two sides have in common. One, they both have a 3x. So I'm going to go ahead and I'm going to write this with a 3x that they both had in common. I'll pull that out. Now, what am I left with in the first piece? Well, I take away the 3, I take away the x. I'm left with just a singular x. I bring that plus sign with me. Well, what am I left with here? Well, the x is gone. The 3 of the 6 is gone. So I'm left with just 2. There's my final answer. All right, now let's go to question 2. All right. What do they have? What do all 3 terms have in common? Well, the first thing I see is that they all have x's. The first piece is an x cubed, so there's 3 x's there. X squared, so there's 2 x's multiplying, and then an x. So I know I can take out an x from all 3 pieces, but only one, because that is the smallest that one of them has, right? So we can only take out what they all have in common. So they each have 1. Obviously, the x squared has 2 and the x cubed has 3, but they all share at least 1. So we can take 1 out. Then we're looking at 25, 15, and 60. Now, there are factoring sheets that we can provide to you that help you with this piece of it. But basically, what I'm looking for here is I'm going to look at all the factors of 25. And I'm going to do all the factors of 15. And I'm going to look at all the factors of 60. And there's a sheet that I can provide to you guys. If you just send me an email, I can get it for you. 4 and 15, just 5 and 12, I think. 6 and 10. All right, so these are all the factors. Now, what factor do they all have in common? Well, they all have a 1, but that doesn't help us. Only one of them has a 25, but they all have 5s. So that means we can take a 5 out. And then 25x cubed was going to be an x squared now because I took 1 x away. Well, I took a 5 away, I'm left with just a 5. Negative 15x squared, I'm going to keep the negative. Well, that x squared becomes just an x. I took one of them away. And that 15, what I'm left with is a 3. And I have a plus 60x. Well, the x is gone. I pulled it away. And then what is it left with when I take 5 out of 60? I'm left with a 12. And there's my final answer. So I'm just looking at what all these things have in common. So I'm going to kind of do the next one a little bit quicker. So I took a 3x out. So they had a 3, 12, and 36. The common factor between 3, 12, and 36 is 3. You may need to do a little bit longer ways to test it or look at a factor sheet. But I know that the greatest common factor between 3, 12, and 36 is going to be 3. And then we have an x cubed and x squared and x, where I can only take the smallest number of x's that they have, which would be 1. And I pulled that out. And then one thing that we could do if we wanted to double check ourselves is we could distribute this back in. 3x times x squared is 3x cubed. 3x times 4x is 12x squared. 3x times 12 is 36x. All right, I'm going to do 5. Now, first thing I'm going to do on this problem, the very first thing before I do anything else, is I'm taking a negative out. Very first thing. All right, so I take a negative out. All right, and then what this allows me to do, well, I just take negative out first because I don't like seeing a leading coefficient with a negative. So I could have kind of combined that step with all the rest of them, but I want to emphasize if I see a negative leading coefficient, I pull the negative outside, and I just take just switch all the signs. Now I'm going to go a little bit slower on this one, just to maybe prove up, just show this a different way. I'm going to look at the x's. We have x to the fourth, x cubed, and x squared. So the most that I can take out is an x squared. All right, so I go ahead and do that. All right, now what number can I take out of 3, 6, and 9? It's going to be a 3. And there, that's it. So there's a couple different ways. I kind of done both a couple different ways. All the same concept. Choose what you have, and as always, if you have more questions, just reach out to me. We can do a follow-up. Now we're going to do factoring by grouping. All right, we'll start with 8. If we look at this, they have the same thing under in the parentheses. So because they have the same thing in the parentheses, what I'm going to do is I'm going to take the little coefficients, I guess we'll call them, the numbers in front multiplying the parentheses. We're going to take those. I'm going to write them as a binomial. Put them together, so 3x minus 5 because it's negative. I put it in a binomial. Then what I'm going to do is I'm going to take the other piece, the 2x minus 7 they both had, I'm going to write it once. And there is my factoring by grouping. All right, cool. So how do you do it if you actually have a full problem like number 9? Well, how I'm going to do this, I'm going to adjust my screen here. How I'm going to do this is I'm going to go ahead and I'm going to factor the first 2, and I'm going to factor the last 2. X cubed plus 3x squared, what can I take out of this? I can take out an x squared. And that leaves me with an x plus 3. And what can I take out of 7x plus 21? I can take a 7 out. And as you can tell, we have an x plus 3. And then I'm going to take an x squared plus 7. And then I have an x plus 3. And there's my factor. How do I know this is going to work? Like, how do I know factoring by grouping will work? Well, when I do it, when I choose, I'm going to factor the first 2 pieces, factor the last 2 pieces. When I do it, the parentheses, what I get matches. If I got an x plus 3 and an x plus 2, I would not be able to use this method. So if it works, it works. If it doesn't work, we have to try a different method. And the good news about this is this doesn't take a lot of time. We can kind of check it real quick. All right, so we have a 4-term polynomial. We'll separate the first 2, separate the last 2. Well, 2x cubed minus x squared. Well, the 2 and the 10, I can take a 2 out. X cubed and x squared, I can take an x squared out. And then with x minus 5. I have 3x and 15. Well, between 3 and 15, I can take a 3. There's no x I can take out. X minus 5. And again, my parentheses are the same, so I take the numbers in front, 2x squared plus 3, and then I take the number that was repeated in the parentheses. And I'm done. That's it.